lesson 3.3 regarding proofs of parallel lines. So as we discussed in class, one of the issues with the corresponding angles postulate is the converse. I'm sorry, not the converse, but is the proof of it. And textbook lists it as a theorem. I've seen it elsewhere listed as a postulate. One of the things that we're going to do is we're going to do a construction here. So we're going to need a compass, and you're going to wind up doing this on notebook paper. On your compass, what we're going to wind up doing is constructing a straight line. So I'm going to actually have my software do this. There we go. Nice straight line. Effectively, what we're going to do is we're going to construct off of a point, we're going to construct the same angle. And when we do that, it's going to wind up constructing parallel lines. Okay, and this is, again, which is where Euclid kind of has the wheels come off the wagon for his postulate, postulate 5. Because we can demonstrate this, but it doesn't really seem like adequate deductive proof when we do that. Let's go ahead here. I'm trying to arrange my compass to actually use the stylus, which is a new endeavor here. Okay, here we go. So I'm going to go ahead and I'm going to put the point of the compass here. I'm just going to mark a point on the screen here, and I'm going to see if I can actually navigate this thing. So I'm going to make an arc mark with my compass. Okay, kind of worked. And when I do that, I'm going to keep that arc mark fixed. Okay. And that's going to be the angle, but I need to make it shorter in this case. Okay, so smaller arc mark, because what I'm going to do is I'm going to show that I'm going to create this angle off of both that point and that point. Okay. So I just have a fixed distance from the point to that arc mark, and I kept the same distance, right? So I put the needle on both those points that I have on the line and then out in space. Now separately, this is what I need to do here, is I need to take that fixed distance okay, and copy this angle. This distance is the first thing I need to do is I need to actually draw the line that's going to go through. So using a straight edge through these 2 points. Okay. Again, I need to make sure that my arc is going to deepen a little bit here. It's going to be a little bit further. Okay, so take this distance and I'm going to spread the width of the compass for this, let me show you guys here, for this bottom angle, okay? I need to copy that angle. So what I'm going to do, I'm going to spread the compass where the needle and the point of the pen are going to be, oops, it's tough to do. And that's the fixed distance that I'm going to take, is from this angle. I'm going to go ahead and go up, right, to the second arc. And that way I have copied this angle right here, right? Because I have now copied that distance. Now you see I have this intersection right there. When I connect these 2 points, what I'm going to have accomplished is parallel line. Okay, so let me actually go through here. go through these 2 points right there, and now I have the same angle here. This guy is congruent with this guy, right? Those two angles are copied. And those lines are parallel. Okay, so that's effectively showing that and again, in the case of two parallels, right? I'm going to have this transversal that goes through them and showing that those two corresponding angles are going to be congruent. So now that we have that, what we need to do is a proof. But real quick, I'm going to make sure that I put out two theorems, which is if two lines in a plane are cut by a transversal and corresponding angles are congruent, then the two lines are parallel. So if you had a tough time with that construction, just as long as you can kind of pick up these two theorems, because these are, I'm proving these things to be true, is not a line. There is just one line through that point that is parallel to the line. Okay, so these two theorems that are a result of what we've actually demonstrated up above. Okay. So, do a quick proof here, similar to what we actually accomplished in class yesterday. We did this with alternate exterior angles. But I'm going to show you guys here real quick. We have angle 1 congruent with angle 8, and we're going to prove M parallel to N. Okay, so we're actually going to prove parallels here. So here is our diagram. So we have the two lines. These are lines M and N. The line cutting the two of them is L. But notice these are not marked as parallel, okay? What we have here is a series of angles, 1, 2, 3, 4, 5, 6, 7, and 8, okay? And we need to do our two column proof. So we divide that up. We have our statements on the left, our reasons on the right. Okay, so again, starting with our given, we have angle 1 congruent to angle 8. Right. Well, where do we go from here? Well, think about what's going to be congruent to angle 5, right? It's going to be angle 8 again, right? So 5 congruent to 8, right? These guys right here. Their relationship, of course, we know, is that these are vertical angles. So the same logic that we employed in class in a previous lesson. We know that angles 1 and 5 are going to be congruent, and that's because these two angles are corresponding angles. Therefore, before we even say that they're corresponding, the other issue is that transitively speaking, right? 1's congruent to 8, 5's congruent to 8, therefore 1's congruent to 5, okay? And what we're going to employ here is that since 1 is congruent to 5, the conclusion we can make through those theorems that we just established is that M is going to be congruent to N, and that's going to be because the corresponding angles parallel, okay? Theorem. Sorry, actually, we're going to list this as a postulate. It's a bit of a fine point to make here. Okay. Moreover, I think we're actually going to stop there and actually give you a chance to attempt the assignment. Just making sure that we understand, when we actually see that relationship, the other one that we'll see has to do with the supplementary angles that we can establish, because the last thing that we want to make sure that we put in here is that all the other things that we're going to conclude from that previous argument, which is this. And so again, if we have angle 1 congruent to angle 8, make this a little bit larger, then as n is parallel to n. Moreover, here's the last few things for this lesson. If the angles are alternate exterior and congruent, then lines are parallel. If angles are alternate interior and congruent, right? Because we could perform the same exact proof showing that those those lines are still going to be parallel. Because we could perform the same proof showing the congruent. So again, it's going to work for if they're parallel. So this is effectively a converse of what we were working on before in the previous lesson. Then lines are parallel. Next, consecutive interiors. Right? They're not congruent. Consecutive interior angles are supplementary. Remember? And lines are parallel. One more. So we have two lines perpendicular to the same line. The lines are parallel, which effectively is just supplementary angles, right? Because if lines are perpendicular, what I've formed is two 90-degree angles, right? Well, the sum of those two 90-degree angles are going to be supplementary. Therefore, right, we're gonna have the same instance. Either you could apply that as being consecutive interior, right, or with being supplementary, or actually if they're both 90. The angle that's adjacent is also going to be 90, which therefore would establish corresponding angles. So go ahead and complete the assignment. It's posted on Canvas. Good luck.